Evening, everybody. Well, tonight we're going to take a look at something you should be fairly familiar with, scientific notation and powers of 10. But I still want to go over it. We'll take a look-see at how we write things in scientific notation, in standard form, and how we can use the power of multiplying and dividing by 10 to make our life easier when we're dealing with big and very small numbers. So let's get started. So what does the power of 10 do for us? Well, let's just take a look very simply. 10 times 10 is how many zeros are there? Well, we have 1, 2 zeros. Everybody knows that 10 times 10 is 100, but we can write that as 10 squared. I have 2 zeros. My exponent is 2. 100 times 100 is 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. And I can easily write that 10 to the fourth. So the corresponding exponent always matches with the number of zeros. 1 over 10 times 1 over 10 is 1 over 100, which we learned today is the same as writing 1 over 10 squared, which is the same as writing 10 to the negative 2. Well, how do we get 10 to the negative 2? When we looked at this, we take a look at point 0.01. We move it over 2 spaces, and that also means that I move it over 2 spaces, and I get 10 to the negative 2. 1/100th and 0.01 are identical, 1 over 10 squared, and the nice notation with a negative exponent, 10 to the negative 2. So using that rule, we move the decimal point 2 spots. Here we're going to move the decimal point 1, 2, 3, 4 spots. My number is small, so my exponent must be negative. Easy. All right, let's move on. So, some things to remember. 10 to the first is 10. 10 to the 0 is always 1, and 10 to the negative 1 is 1 over 10, or 0.1. And if you forget, this is the greatest way, if you forget these rules that we just went over here, go back and write 10 to the first is 10, 10 to the 0 is 1, 10 to the negative 1 is 1/10 equals 0.1. How many places do I move the decimal place? 1 place. Okay? If the number is less than 0, my exponent must be a negative number. Okay, so if you remember these 3, you can build the rest of all of the scientific notation, all of the negative exponents, if you can just recall 10 to the first is 10, 10 to the 0 is 1, and 10 to the negative 1, 1/10. Move a decimal point 1 spot. All right, so multiplying by powers of 10. If I'm multiplying by powers of 10, this makes your life so easy. We are going to multiply by 10 to the 6, which means my number is going to be bigger. How much bigger? It's going to have 6 more zeros, but we actually have some places here. So I'm just going to move the decimal point 1, 2, 3, 4, 5, 6, 9, 7, 8, 6, 1, 2, 3, and I always like to put my places in there. Okay, so if my multiplying by 10 to the 6 makes my number big, what do you think multiplying by a negative exponent makes my number? Absolutely, it makes it smaller. How many places do I move it? 4. 1, 2, 3, 4. So my answer here is 0.0019 point. Oh gosh, sorry. 0.0195. All right. So, multiply by powers of 10. If it's a positive exponent, I'm just going to move the decimal point, however many the exponent is. Multiplying by a negative exponent, I'm still going to multiply by the same number. I'm still going to move the decimal point, the number, but I'm going to move it to the left. If you can't remember, just think. Need to make my number bigger, move it to the right. Need to make my number smaller, move the decimal point to the left. Well, that all brings up the beautiful form of scientific notation. And scientific notation is used a lot when we deal with very big numbers or very small numbers because it allows us to write numbers in a format which is easier to use and easier for multiplying, dividing, etc. when we're dealing with those big numbers. So there's a couple of rules that you need to remember, and you should have learned already, but we'll go back over them. The first part is, the first part of the number is greater than or equal to 1 and less than 10. So, for example, we have a number here, 3.5 is greater than or equal to 1 and it's less than 10. 9.98 greater than or equal to 1 and less than 10. A counterexample would be 0.93. Okay, that number is not greater than or equal to 1. So we certainly want to use that when we're in scientific notation. The second part is we just write times 10 to whatever the power of 10 is. Okay, so times 10 to the 11th here, times 10 to the negative 2. So this number is big or small? Big, absolutely. It's multiplying by 11 place markers. Big or small? Small. This is going to be moved how many places to the left? 2. So if we were going to write that, we would move the decimal point to the left 2 spots. So let's see how we write certain numbers in scientific notation. So here we have 778,400, and our requirement is the first part of the number is greater than or equal to 1. So we're going to have to move the decimal point until we have a number between 1 and 9. So we're just going to move the decimal point. If I moved it again, I'd have 0.78. If I don't move it, I have 77. I need to get to here. I then copy down all the numbers until I'm left with just zeros. So I've copied down all the numbers. Now how many places did I move my decimal point? I moved it 3, 6, 7, 8. So now I multiply times 10 to the 8th. So if I was to move this in the opposite direction, I would just move it 1, 2, 3. How many? 8 spots, and I would come back to the same number. All right. Got to move the decimal point. This time I have to move it to the right until I get a number between 1 and 10. So here I have 3.5. I have numbers, so I have to keep writing until there's only zeros left. How many places did I move the decimal? 1, 2, 3. And is this number smaller or greater than 1? Well, it looks like it's smaller, 0.003509. So again, 1, 2, 3 times 10 to the negative 3. And we'll have plenty of time to practice that in class tomorrow, but that's how you build a scientific notation form. So obviously we can do the opposite of that. In standard form, I just 5 and I'd start moving the decimal. 1 place, 2 place, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Move the decimal. Going to move the decimal here. Is my number going to be a big number or small number? My brain says negative exponent, small number. So I'm going to move it. I'm going to have 1, 3, 6, 0, 9. I'm going to move it 1 spot. 1, 2, 3. And so my now number is in standard form. So if I write it and it looks like this, we have standard form. If I write it and it looks like this, we have scientific notation. Okay, well, I will see you tomorrow. We'll have plenty of practice. Your only assignment tonight is to complete the worksheet and do one Khan Academy assignment, your choice, of one of the 3 that's been assigned, and unlock your dashboard. Good night.